In this video, we're going to go through Lewis structures of covalent compounds. Now, we've done Lewis structures once before with ionic compounds. Covalent compounds are different. So when we talk about covalent compounds, we're talking about sharing electrons. In ionic compounds, we have a transfer of electrons between cation and anion. Covalent compounds, we are sharing or pooling electrons between different atoms. Now, the most important thing that you need to know about this is valence electrons. Like, everything comes from the valence electrons. So on our periodic table, the group number helps you determine the number of valence electrons. So this is group 1A, group 2A, 3A, 4A, and so forth. The number in front of the A tells you the number of valence electrons. So nitrogen, for example, is in group 5A. It has 5 valence electrons. If we were drawing out a Lewis structure for nitrogen, it would get 5 dots representing the 5 valence electrons. And we always want to make sure when we draw a Lewis structure for an individual atom that we make sure and give every side 1 dot before we start to go back and double up. So if you look at the figure on the right here, nitrogen has 2 dots on this side, 2 dots on this side, 1 dot on this side, and then none down here. That's no good, no bueno. So we want to make sure that every side gets 1 before we start to go back and double them up. Okay, when we draw Lewis structures of covalent compounds, we always place carbon in the middle. Carbon always goes in the middle when we're bonding 3 or more. We're going to represent unshared electrons with dots, and we're going to represent bonds with lines. So there are 3 types of bonds that we can have in a covalent compound. We can have a single bond, we can have a double bond, and we can have a triple bond. Okay, a single bond looks like this. So you have 2 things and they're bonded with 1 line right here. In a double bond, you guessed it, there are 2 lines right there. And in a triple bond, there are 3 bonds going on, 3 lines. Now each line represents a number of shared electrons. So in a single bond, we are sharing 2 electrons between the 2 species here. In a double bond, we are sharing 4. And in a triple bond, we are sharing 6. So single bond 2, double bond 4, triple bond 6. So here's an example. It says draw a Lewis structure for HF. So we're going to do this in steps. Okay, so step 1 is count the number of valence electrons. So we have hydrogen and we have fluorine. Hydrogen is in group 1A, so it gets 1 valence electron. Fluorine is in group 7A, it gets 7 valence electrons. So we'll add those up and we get 8. Great. Next step. Carbon or solo atom goes in the middle. We don't have carbon in this example. We just have hydrogen and fluorine. There isn't going to be a middle atom because we only have 2. And in order to have a middle atom, you have to have at least 3. So we're going to skip that step. So I'm just going to draw them right next to each other like that. Okay, step 3 is connect to central atom with a single bond. Okay, so I'm going to subtract 2 that we are bonding here. And we have 6 remaining. Okay, so step 4 is going to be to place electrons to satisfy octet. So when we say octet, we want to have 8. Everybody wants to have 8 to be like the noble gases. They want to have a full outer shell. The exception here is going to be hydrogen. Okay, hydrogen only wants 2 electrons. Okay, so when we do this, both hydrogen and fluorine can claim the 2 electrons that are being shared. So in this case right here, remember this right here is 2 electrons. So hydrogen gets to claim those 2. Hydrogen's happy, it's got its full shell, it's got 2. Fluorine only has 2. Fluorine wants to have 8. So we are going to give fluorine, we have 6 dots remaining, 6 valence electrons remaining, so we're going to draw those. So 1, 2, 3, 4, 5, 6. And that's it. So again, hydrogen gets to claim the 2 in the middle. It's happy. Fluorine gets to claim the 2 in the middle. And then it also has 2, 4, 6, plus the 2 here is 8. So fluorine is happy. Done. All right, let's move on to our next example. We have O2 here. Okay, so step number 1, count up the number of valence electrons. Okay, so let's go back to our periodic table. And if we look, oxygen is in group 6A, so it gets 6 valence electrons. But there are 2 of them. So we have 12 here. Okay, we only have 2 atoms. There's no carbon, so we're going to just place these next to each other. Single bond everything together. So I'm going to subtract the 2 that I am bonding here. 12 minus 2 is 10. I have 10 left. So let's go ahead and place the 10 where I can to fill everybody up. So oxygen wants 8. Again, both oxygens can claim the 2 in the middle. So looking at the oxygen on the left side, it has 2, 3, 4, 5, 6, 7, 8. So it's happy. I've used up 6. I have 4 remaining. So let's go 1, 2, 3, 4. So I've used them all up. Now we just want to make sure that everybody has 8. So the oxygen on the left claims the 2 in the middle. 4, 6, 8. So the one on the left is happy. The one on the right has 2, 4, 6. So the one on the right is not happy. So what's going to happen in this case is we are going to take 2 from the left side and we are going to share them in the form of a double bond. So now both sides have 8. And just so you don't think that I'm doing some sort of crazy magic here, crazy accounting, I had 12 total electrons. Okay. Here in the middle, I have 4, 6, 8, 10, 12. Okay, so that's where all 12 electrons are. They're all there. We're just moving them around so that everybody has 8. And that's what we do when we draw these Lewis structures. So in this case, we are good. We're done. Okay, here's our next example, nitrogen. So let's go ahead and count them up. So each nitrogen, let's look at our periodic table. Each nitrogen has 5. So got 5 here, and there are 2 of them. 5 times 2 is 10. So let's put a nitrogen here, bond them. And we'll do the same thing. Let's try to place them where we can. 1, 2, 3, 4, 5, 6, 7, 8. All right. The nitrogen on the left gets 2 from the middle. 4, 6, 8. It's happy. The nitrogen on the right has 2, 4. So we're going to do the same thing that we did in the last example. I'm going to take 2 here and 2 here, and I'm going to create a triple bond. So in the middle, we have 6 electrons that are being shared, and then each nitrogen has a pair of electrons for 8. And now we are good. Okay, this one's a little larger and a little more difficult. Let's go through this. So we have carbon and we have hydrogen. Looking at our periodic table, carbon has 4, Hydrogen has 1. There are 4 hydrogens. Okay, so 4 plus 4 is 8. Now this example has carbon, so we're going to put carbon in the middle, and we are going to make sure that hydrogen is all around it because it's in the middle. So it'll set up like this. And now we are going to bond everything. 2, 4, 6, 8. Okay, we don't need to draw any dots here, and here's why. Every hydrogen needs 2 electrons to be happy, and guess what? We have 2 electrons that are being shared here between carbon and hydrogen, so it's good. Carbon needs 8 to be happy. Each bond counts as 2. 2, 4, 6, 8. Carbon's happy. So we're done here. Okay, this one's a little harder. Let's go through and let's count up all of our valence electrons. So we did nitrogen once already, and it was 5. Iodine is in group 7. It has 7 valence electrons. There are 3 of them. 7 times 3 is 21. If we add these up, it is 26. Okay, no carbon, but we have nitrogen, which is by itself. So nitrogen will go in the middle, and we are going to put iodine all around it, like that. Let's single bond everything. 2, 4, 6. Okay, and then just like before, let's go ahead and start filling in dots where we need them, valence electrons. Okay, so each iodine has 2 and they need 8. So I'm going to give each iodine 6. Six times 3 is 18. Okay, I have 2 left. So all of the iodines are happy. Let's take a look at nitrogen. Nitrogen has 2, 4, 6. It has 2 more dots, and it needs 2 more dots. Perfect. We are good. All right, let's do one last one here. So we have carbon and we have oxygen. Carbon has 4, oxygen has 6, and there are 2 of them, which makes 12. 16 total. Carbon goes in the middle. Oxygen goes on either side. Single bond everything. That's 4 that we've used in bonding. 16 minus 4 gives us 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now you might be tempted to stop here. You're like, look, all the oxygens are good, but let's take a look here. So each oxygen gets 2 from the shared bond here. 2, 4, 6, 8. Same thing on the other side. But carbon only has 2, 4. So we are going to take 2 from here, and we are going to bond it here. And we could also take 2 from here. Oops, accidentally erased our oxygen. Like that. That is correct. Now I want to show you something else. So let's go back to what we had before. And it was like this. Okay, so here's another structure. What if, because carbon needs a total of 8, what if I had done this? What if I took 2 from this side? So instead of doing a double bond on both sides, what if I did a triple bond on that side? Or what if I flipped it around and did the triple bond on the right side? Oops, that's too many. There we go. Okay, These are all they're not the same structure, obviously. They are all technically correct. We've satisfied the octet. There is a way to determine which one is the most correct, but that is outside the scope of this lesson. So technically, this one here is the most correct. These here are also, for the purposes of what we are doing, correct. So there sometimes are multiple ways to draw structures. There is a way to determine which structure is the most correct, but again, for the purposes of what we're doing right now, we'll just say that those other structures are technically correct. And that is how you draw Lewis structures.